Hey, this is Alchemist Camp, where we learn the Elixir programming language and we learn it by building things. In Lesson 8, I challenged you to check out the Elixir docs on, or I should say the guide on comprehensions. And more specifically, I also challenged you to build a deck of cards. So we're going to generate it from lists of suits and ranks. This is not terribly complicated, so I will type the whole thing out from scratch. We'll first make a file, challenge8.ex, and then we'll make a module. Well, not a macro, a module, and we'll call it ch8, and define deck. And we could make some options to pass in a pinnacle, for example, if we want to make a pinnacle deck instead of a bridge deck. We'll start with the standard bridge deck though. And we're going to use a sigil here, which will make it a little bit easier to make a list of strings. So suits equals tilde w. This is a sigil for a list of words. And our suits are spades, hearts, don't need any commas, clubs, and diamonds. Close it like that. Okay, and then the ranks are just going to be numbers 1 through 10, and then Jack, Queen, King, and Ace. And let's see, we can make the ranks just by... And the ranks are going to be the numbers 1 through 10, and then Jack, Queen, King, and Ace. And we'll assume that we've got a range to string function that will convert the range 1 to 10 into a list of strings. And then we will append that to, or we'll prepend it to Jack, Queen, King, and Ace. And in fact, we don't even have to generate the ranks like that, but what the heck, we'll do that. And then we'll do for each rank R and each suit S. It's going to come from ranks. We'll do R, which is a string, concatenated with of concatenated with S. So we'd have like the 2 of spades or the ace of diamonds and so on. And that's pretty much it. We just need to write our range to string function. And this is just going to be a one-liner. So let's see, we'll call it rtos on range. We'll do enum.map over the range, and on each element of the range we will call integer to string. So integer dot to string, and that should be it. So let's save it and give this a shot. ex.bat, compile ch8.ex, and what's wrong here? Undefined function R. Oh, okay. Range. Okay, and ch8.deck. That looks pretty good. All right, so now that we've done that, let's play around with some other stuff. I'm assuming you've probably looked at the file because that was way up at the top of the documentation page, or at least if you looked at anything, you probably looked at that. So let's look at what you can do with binaries. So you know strings are represented in a binary representation. So if we inspect that, we see reference modules, string, and the Erlang module, binary. There's another syntax for binaries. It looks like this. We can take a character from the characters hello world. And actually, we don't want that space there. We can take a character from that, and then for each character, let me bump up the font size a little bit here. Then for each character, we just print it out. I forgot the 4. That's all. There we go. We see hello world. This is a list of characters because I wasn't putting them into a string. I was just getting the characters out, but we can do that. And now we have a list of strings of each of those characters. That's not super interesting, but we can do stuff like add a filter to remove one thing. So we could say like take everything from hello world unless that thing is an L. And this syntax that you see here, C does not equal L. This syntax you see with the question L, that simply gets the ASCII value of an L. So if we do this, L is 108, and we can see by looking at a list with just 108 in it, 108, not L08, that's the same as the character L. So up here we could just do 108, get the same result, but this is a bit clearer. So you see the hello world except for the L's. Now as before, you can do into. So we could put all of this into an empty string, and now instead of getting a list of single character strings, we'll get it all in a single string. We can also do we can construct all the combinations of, say, A, E, I, O, U, and I'll call these vowels, actually, make that V, and then C will be some consonants, like, I'm not going to type them all out, but say B, C, D, F, G, H, and do that. Undefined function. All right. Now you see we're just repeating the consonants, the number of times of the vowels we have. But we could say put out C and V. And now we've got a whole bunch of nonsense. And if we want to put the nonsense into a string, once again, not too hard to do. All right. Then the most complicated example, you may remember from math class long ago that the length of the sides of any triangle, or any right triangle that is, has a relationship where the length of one side squared plus the next side squared is equal to the length of the longest side, or the hypotenuse, squared. And we're going to use comprehensions. So we'll make a function to find triangles with integer side lengths less than n, and def triangles n. When n is less than 1, we don't want to use comprehension. We'll just bail out completely. So we'll return an empty list. And for any other n, we'll do 4 numbers between 1 and n. So we're going to check all the integers up to whatever n is for possibilities for the length of each side. And this is kind of an expensive calculation to do because say n is 10, well then we'd actually check 1,000 possibilities for triangles because it's 10 times 10 times 10. And if n were 100, then it'd be 10 to the 6 possibilities, or 100,000. One thing that'll help us quite a bit here is filters. We'll start with one that says C must be greater than or equal to B, and then one that says B must be greater than or equal to A. Together, these two will make sure that every tuple we return is sorted from smallest number to largest number. And this is worth it because we're getting rid of a whole bunch of the search space, and we're just not going to get different permutations of the same solutions. So after we've found that 3, 4, and 5 could be the lengths of the sides of a triangle, we won't then also go on to find that 5, 3, 4 and 4, 3, 5 are valid lengths of the sides of a triangle. We'll add in another requirement that A plus B must be greater than C. The reason for that is because we know from the Pythagorean theorem that A squared plus B squared must be equal to C squared, and if that's true, then A plus B can't be less than C, because the squares of them wouldn't be big enough otherwise. And if it were equal to C, that would mean that either A or B was 0 and the other one was equal to C, so you just have a 0 length side and 2 lines on top of each other, which isn't really a triangle either. And then our solution is all of these where A times A plus B times B equals C times C. And finally, we'll print out the answer, A, B, C. All right, let's have a look. We'll reload 8. Triangles, goals, let's say 5, because I know 1 is 5. 3, 4, 5, that's the famous one. How about 10? That's not so interesting. That's just a triangle exactly twice as big as the next. I know 13 was 1 though. 5, 12, and 13 is a Pythagorean triplet. How about if we look at all the ones up to 50? Okay, and 100 should be doable with this algorithm. And look at that, 89 is a prime number, so who knew? 39, 80, 89 is a possible set of lengths for sides of a triangle. That concludes our brief tour of comprehensions, and as you can see, they are pretty neat and pretty useful. Also, this tilde W sigil is pretty useful too. Until next time, code on.